Hello friends, we are continuing our topic leveling. In that areas and volumes, how to calculate the areas and volumes with the help of the contour data or the leveling data. That is the next topic. So the calculation of area is carried out by any one of the following four methods: mid-ordinate method, average ordinate method, trapezoidal rule, Simpson's rule. These four methods you may hear in your school level, or some formula you may be applied somewhere else. If not, you try to remember that also, or we will see in the next thing. Mid-ordinate rule. What is mid-ordinate? From the name itself, if there is two ordinate, the mid-ordinate we have to take, that is the 2 ordinate by 2. That is the mid-ordinate rule. So from the figure here they have given the data. You consider this 1 ordinate, 2, 3, 4, 5, 6, 7 ordinates. It may go n number of ordinates. So let be O1, O2, O3 up to On be the ordinates at equal intervals. Here it is 10 meter. It may be equal interval. That equal interval, the common distance, most of the is denoted by D, right? And the ordinates are represented by H. So the normal ordinates are O. The mid ordinate is O1 plus O2 by 2 gives the mid ordinate, that will be represented by H. H1, H2, H up to Hn mid ordinates, right? And L is the total baseline length, right? So the area of the plot, then it will be the D is the common interval distance into the summation of all the mid ordinates. That is H1 is O1 plus O2 by 2 plus, like that it is keep on going. So if you write the formula, you will see D by 2 into O1 plus On plus 2 times all the ordinates. That is the general formula for the mid-ordinate rule. You can remember that way also, right? Average ordinate method. Here the same notations are used. O1, O2, On are ordinates, are offset at regular intervals. L is the baseline length. N is the number of divisions, and the n plus 1 is equal to number of ordinates. Here the area is calculated by O1 plus O2 plus up to On divided by n plus 1 ordinates into the baseline length L, right? The sum of ordinates into length of the baseline divided by number of ordinates. You try to remember this way for the average ordinate method. And the third one is the most important one, trapezoidal. From the name itself, the area is considered as trapezium shape. While applying the trapezoidal rule, boundaries between the ends of ordinates are assumed to be straight. Thus, the areas enclosed between the baseline and the irregular boundary line are considered as trapezoids, right? The same notations here. Let O1, O2, O3 up to On as the ordinate at equal intervals. D is the common distance between two ordinates. Then the first area of trapezoid of the thing, say for example in this diagram, this also considered as trapezium, all are considered as trapezium, right? So this trapezium, how it is, the first area is equal to O1 plus O2 by 2 into the common distance D. Second area O2 plus O3. So from here you can see O2 appears 2 times, O3 up to On minus 1 will come 2 times. So the general formula will become D is common and 2 denominator also common. So the D by 2 can be taken common, the product into O1 plus ON, this will be single time, remaining all the things are 2 times, all the ordinates, right? So in statement, if we said the sum of first and last ordinate twice the sum of intermediate ordinate is added, this total sum is multiplied by the common distance D. Half of this product is the required area, and this method has no limitation for the rule. This rule can be applied for any number of ordinates. That is the most advantage. So in general, this is the formula, but compared to the next method, this will be little bit less accurate, but it can be applied for n number of ordinates. That is the major advantage of trapezoidal rule. Next is the Simpson's rule. In this rule, the boundaries between the ends of ordinates are assumed to form an arc of a parabola. Say arc of a parabola. Hence, Simpson's rule is sometimes called as parabolic rule. Consider the figure. Ordinates O1, O2, O3. The common distance is D. Right. The ordinate values. You can. This is the parabolic thing. How to determine the area is the general formula you obtained is total area is equal to D by 3 into O1 plus ON, the first and the last, plus 4 times even ordinates O2 plus O4 plus O6 up to ON minus 2 plus 2 times odd ordinates O3 plus O5. It's keep on going, right? So 4 times sum of even ordinates plus 2 times sum of remaining ordinates, and the first and last ordinate, the total product is by common distance D by 3, right? This is the thing you have to remember. Limitation is this rule is applicable only when the number of divisions is even. Say here the divisions is 2 and the ordinate is 3. If the number of ordinate is odd or the division is 2, then only this rule is applicable. Otherwise it cannot be applied, but the combination of trapezoidal and Simpson can be applied for such cases, right? So these formulas you have to remember to solve the or to calculate the area, you have to remember, right? Comparison between these two rules. Predominantly these two rules are used in the major fields. In trapezoidal, the boundary between the ordinate is considered to be straight. Here the boundary between the ordinates considered to be parabola. There is no limitation, it can apply for any number of ordinates. Here odd ordinates must be there. It gives an approximate result, it gives more accurate result, right? This is the comparison between these two methods. Consider the following offsets are taken from a chain line to an irregular boundary towards the right side of the chain line. Common distance is equal to 25. If it is not given from the table, you can see 0, 25, 50. It is keep on increasing by 25. So the distance is 25. And the offset values were given, that is O1, O2, O3, O4, O5, O6, O7. So it is odd. So Simpson rules. If it is odd, directly try to apply the Simpson. If it is not, you try to apply. Some problem they ask to solve in all the methods, right? Here we solve by Simpson's rule. The area is equal to D by 3, the formula, plus 2 times odd ordinates plus 4 times even ordinates. So the D here is 25 by 3, O1 plus O7, O1 plus O7 plus 2 times odd ordinates 3, 5, right, plus 4 times even 2, 4, 6. If you calculate all the things, you will obtain the value 843.33 square meter. You can try this for trapezoidal rule also, right? Right, now this is the formula you try to solve in all the 4 methods. The following offset were taken from a chain line to an irregular boundary line at an interval of 10 meter, that is common interval D is equal to 10 meter. and the offset ordinate values are 0, 2.5, 3.5, 5, 4.6, 3.2, 0. Compute the area between the chain line, the irregular boundary line, and the ends of the offset by mid ordinate, average ordinate, trapezoidal, Simpson. We will see, or we will solve one by one. Mid ordinate rule. We have to obtain the mid ordinate. Here they are given as O1, O2 like that. So mid ordinates H1 is equal to O1 plus O2 by 2, which is equal to 1.25. Similarly H2, H3, H4, H5, H6, right? So we have obtained the mid ordinate. If the here see, there are 1, 2, 3, 4, 5, 6, 7 ordinates is given, but the mid ordinates are 6, right? So the required area is equal to common distance into the summation of mid ordinates, that gives the area as 188 meters square, right? Next is average ordinate rule. Here the common interval again the same. The number of division is 6, base length is equal to, then 10 into 6 is equal to 60 meter. Number of ordinates are 7, so required for area is equal to d into all the ordinates. All the mid ordinates have to be added, and it has to be divided by n plus 1. I think you remember n plus 1, right? So if you obtain this, you will get the thing, the area as 161.14. Compared to the mid ordinate itself, the average ordinate, the area get reduced. So the accuracy you can check. Then by trapezoidal rule, for the same data, d is 10, required area is equal to d by 2 into first plus last is, here it is 0 plus 0, plus 2 times the remaining ordinates, right? That gives the area is 188 meter square. It is approximately, or here it is exactly equates with mid ordinate, sometimes it is approximately. By Simpson's rule, for the same data, since it is an odd ordinates is available, Simpson's rule is applicable. The required area is equal to d by 3 into first and last plus 4 times even ordinates plus 2 times odd ordinates. If you substitute those values, you obtain the value as 196.66. So compare with the 4 methods, generally average ordinate, its time being we will use, so it is more or less more approximate. Mid ordinate sometimes it is okay. Predominantly these 2 methods, and the values sometimes they may also equal. When the ordinates are odd, Simpson is the best. If it is even, trapezoidal is the best, right? And next problem, the following offset were taken at 15 meter interval from a survey line to an irregular boundary line. Here the number of offset given is 6, 9, 10 ordinates. So whether I hope Simpson rule is not applicable. If required, we have to use the combination of trapezoidal and the Simpson, right? So we will try to solve this also. First by trapezoidal alone, then Simpson plus trapezoidal, right? So trapezoidal rule, required area is equal to, you know the formula, d by 2 plus first and last ordinates plus 2 times the remaining ordinates. You will get the area as 820.125 meter square. In Simpson rule, if this rule is to be applied, already here it should be odd, but it is in even, so it cannot be applicable. So up to 9 ordinates we try to apply the Simpson rule, and the last portion O9 to O10 we apply the trapezoidal rule. We get add those things, we will get the total area, right? So first A1 is from O1 to O9 area. So there d by 3 Simpson rule, first plus last ordinate. Here the last ordinate becomes the O9 plus 4 times even plus 2 times odd ordinates gives the area as 756.00 meter square. And the last small portion O9 and O10, the area is trapezoidal rule, that is d by 2 into O9 plus O10, which is equal to 57.38 meter. So the total area is 813.38 meter square, right? More or less trapezoidal rule and the Simpson rule are very nearer to each other, right? So this way also you can apply when the Simpson rule is not applicable. This way you can solve it, right? I hope you have understood the calculation of area. You try to answer the questions asked in the quiz. Thank you.